Good morning, class, or I should say classes. Let's say good morning. We're going to do the lesson on the scientific revolution and the leaders that were important. So I already gave you your assignment. What you need to do is watch the whole video and write me a paper, 1 page, who you felt was the most important and why. And then that's it for the week. Many of you are turning in all your stuff, and I'm very well aware of that. I already sent the email out what's going to happen. So without further ado, 3, 2, 1. And I'm about to teach you, salute you back. Strength and honor. So last week we learned about the Enlightenment and the Enlightenment writers, and part of that lesson included a section about the leaders of the scientific revolution who approached the Enlightenment from the scientific viewpoint. So today, that's what we're going to look at. This lesson will not be too long. So without further ado, let's ado. All right, so what is the scientific revolution? What happened? What was it? How did it occur? Who did it? Well, from 1500 to 1700, and notice the date now, we're getting into just about the founding of the United States of America. Next year in 8th grade, you will begin your course of study from a certain date, roughly, and that will be where it goes from. So in 8th grade, you will be learning about the founding of the United States on from around this time period. So it really coincides with each other. So people began to question accepted views of the world, especially the teachings of the Catholic Church. Now, again, this is not, and nor would it ever be, an attack on the Catholic Church or the Catholic faith. This is historical accuracy when you have to learn that the big, I don't want to say obstacle, but to a lot of these views was the Catholic Church's understanding of what science was and what it was doing. And there should never be a conflict between science and belief. But in today's environment, there's a big divide, and there doesn't need to be. And it's not because science removes religion or religion removes science, is they're talking about two separate things. And I'll go into that a little bit later. But just keep that in mind, okay? Keep percolating in your mind. So, influenced by ideas of humanism and the Renaissance, we learned what these ideas were. We learned what humanism was. We learned about the focus on the individual. So we are going to continue. So who were the scientists? Who were these gentlemen? Look at this library. I mean, my goodness. If I turn my computer around, you can kind of see my library right now, but I'll give you a little peek if it'll work. Switch it around, I'm messing things up. Oh, look at all these books. You guys always wondered all my books at home. Well, here's a quick little shot. You can kind of see that. There we go. So let's continue. Who were the scientists? Well, the first scientist is Nicholas Copernicus. What a cool name. Huh? And what did he do? He was a Polish astronomer who developed the idea that the sun was in the center of the universe, which is known as heliocentric, and the planets revolve around it. Now, in this time period, universe was what they could observe and such. Today we call it the solar system. Right? Solar meaning sun, system meaning system of planets and other objects orbiting around in an ellipses, for those of you who love science, as I do. And that is what they called it. But this time period, it was the universe. And this is very different because at the time they thought something else was the center of the universe. And you can see right here in this picture, Sol, the sun. And notice the orbits are perfectly circular. They didn't understand there was an ellipses. Well, I'm not going to go into all that detail. But Copernicus, very important. Okay? Galileo, Galileo. Anyway, my attempt at singing the song. No, he doesn't look like me. All right. He was an Italian scientist, first to use and invent the telescope and thermometer. So here's the telescope, thermometer. Proved the theory the Earth was part of the solar system. So he proved that the Earth did not go, or the sun did not go around the Earth, but the Earth went around the sun. And notice, around. Very controversial at the time. He was heavily persecuted. Actually, on his deathbed, his notes were smuggled out and published, and finally able to prove. There's a video I would have shown you. I might, if I can figure out how to do this. I want to show you those videos, but we'll see. I don't want to take credit away from the people who produced them, but I'm just trying. It's something that we use during school, and I just want to make sure that I can do it from home and do the same thing. So you will see. It's a cartoon too. It's pretty good. But anyway, Galileo, very important. I don't know why they wore these outfits, but anyway. For those of you that have had breakfast, we have Francis Bacon, pun intended, English philosopher who wanted people to use rational thinking by using experiments and observation. He invented the scientific method, which was specific steps to follow in an experiment. And so you should have learned this in your science class. You observe an object, form a hypothesis, test the hypotheses, interpret the results to draw a conclusion. Now, if people would actually do this today, can you imagine how much better it would be? Instead of forming an opinion, seeing it on the internet, believing it's true, arguing because they don't believe you're right. That's what people do today. Instead of observing, what does this happen to be? What is going on here? Let's think about it. Let's form a hypothesis. Let's test this. Let's have observable data that we can actually test and observe, and let's interpret the results accurately without opinion. Okay? Sadly, people argue and take sides, and they don't practice this basic fundamental idea that should be used mostly in everything. You know, observe an object. I have a classroom of students. Form a hypothesis. A lot of them like to learn, a lot of them don't. Test my hypothesis. I'm going to teach them and see how well they do. Interpret the results. Some kids do well, some kids don't. What's the rationale behind it? See how it works? Very simple. Okay? Not too complicated, and yet no one does it anymore. Even within the scientific community, there are people who form an opinion, okay, look at some data that they believe is true, they don't really test their hypothesis, assume it's true, and then people argue. So, I gotta get back to Mr. Bacon. All right, his haircut. All right, René Descartes, right? He was a French philosopher who believed that people should doubt until it is proven through reason. You notice the common thread? Reason, thinking, using your brain, okay? Don't just accept things because people say, think about it. You have a brain. You can rationalize and empirically prove these points. And empirically prove does not mean that someone throws a study at you and says it's true. Empirically means there are steps that have been taken, and it can be proven substantially through math, through observation and testing. In history, it's through the evaluation of sources, textual criticism, literary criticism, and so on, that you prove ideas and so forth. Like, how do you know there really was a George Washington? See? There's a reason why people believe those things. It's like actually been proven through the texts and things that have been written. Okay? So, remember that. I think, therefore I am. The Let you ponder that for a moment. All right, now this guy, I've always thought this guy reminded me of like a cholo cousin. Like they got the "Orale pues, dude, what's going on?" Right? This is Johannes Kepler. Okay, German astronomer who proved Copernicus' theories through math laws. So he proved it through math. Also, the planets revolve in oval orbits around the sun. We call them ellipses now. Same thing. But he did it through math. So for those of you that have an aversion to math, you don't need to. There's a reason for it. Okay? It's to do these things that help our lives in society. Okay? Whoa, I'm getting too far over. All right. And I believe you, Van Leeuwenhoek. Gosh, I used to say it. I used to have a challenge in class who could say it. And the kids that had science already knew how to say it. Leeuwenhoek. Anyway, Van. He was a Dutch scientist, was the first to use the microscope to observe the flow of blood, bacteria, and tiny living matter. So you think about everything that's going on today, knowing about bacteria and viruses and such, we take that for granted. In this time period, they were discovering these ideas. And the microscope, I don't know how many of you, raise your hand if you've used the microscope before. I remember the first time I looked at an amoeba in my honors biology class. Yes, I had honors biology. And wow, it was amazing. Because you can't see it, and then you look in the microscope and boom, there it is. It's just amazing. So something very, very changing for the world. So remember, you should write me who do you think was the most important and why. So he just looks annoyed. Wouldn't you be? They did to my arm. Anyway, William Harvey. Right? William Harvey was an English physician, accurately described how blood circulates through the body. He dissected humans for observation. Now, at this time, it was not considered proper, nor something you would do, to exhume a body and examine it for scientific purposes. So they used to take bodies that have been buried and do this sort of thing. Very highly not looked at with happiness and joy. Okay? Anyway, yeah, that's what really happened. Nowadays, you can donate your body to science. They do all these things. If you're a med student or going to med school or biology major, what have you, when you get in your upper division courses, you would sometimes go to see a cadaver. And I know at my school, as a specific, they had a cadaver. They named the cadavers. I'm glad I didn't take that class. But they do this types of observation, dissecting, to figure out how things work. And it's a good thing they do know how it works, because when people get hurt or sick or have you, it can be repaired. Okay. Monopoly person, I always call this guy. This guy invented the barometer. Evangelista Torricelli. Right? And this is an Italian scientist who invented the barometer, an instrument that we use to predict the weather. Now, excuse me. Barometer is basically, if you ever watch the news, this is a high pressure system moving into Southern California, right? It's going to be very hot. And low pressure system moving in, it's going to be stormy. High pressure systems usually have good weather. Low pressure systems is bad weather. And the pressure system, how they measure it, is with the barometer. Now, when I was in high school, we did this in my science class, and we measured the using barometers, the high and low pressure in the classroom, and we were able to graph and map it out. It was very interesting. Very fun experiment to do. Very important instrument that we use today in how we predict the weather. Okay, so. Oh, okay. Before I even say anything, who do you think that is? Sir Isaac Newton. Not Fig Newton, but Sir Isaac Newton. Okay? He was an English scientist, combined all the theories into one. Law of gravity. Gravity is the force that keeps planets revolving around the sun. and objects on the Earth's surface and keeps us from flying off into space. Gravity. But they don't know exactly why or how it works. Okay? They just know the effects. For example, my cup with water, which happens to say Richard with a capital R. Oh, someone's gardening outside. Oh my gosh. But anyway, don't worry about the noise. Gravity is important because without gravity, you know what happens. Okay. Isaac Newton also invented calculus. Amazing scientist, amazing person in history. So, Isaac Newton. All right. Then we got this gentleman here, Andreas Vesalius, who, what do you think he did? You're right. Made many discoveries about the human body, careful dissection. He was able to explain how the body functions. We get veins, the name from this gentleman. Okay. These were his drawings. Very amazing how, I mean, these guys really did some amazing work during a time where it wasn't exactly appropriate to do it. Look at his beard. He's got a cool beard too. So what was the impact of the scientific revolution? What was the result? What occurred? Okay? Scientific revolution was a fundamental change in the direction of Western thought and scientific practice. Okay? Basically, things shifted. Okay? Scientific revolution was not merely a set of discoveries or technical advances, but brought about a fundamental change in the way the laws of nature were investigated. In other words, it wasn't like, ooh, why does this happen? It was, let's really look at this and figure out why and how and learn using reason and logic. The advancement of experimentalism during the scientific revolution and the use of calculus resulted in a new scientific methodology that led to the Enlightenment and to an explosion in scientific inquiry into the natural world. A lot of words. In other words, these things would propel society into the future and all the great discoveries that we have even today. Biology, astronomy, medicine, even in theology and psychology and sociology and all the other ologies were pushed along because of the scientific revolution. So, your job is to look at this video, write me a one-page paper on who do you believe was the most important and why. Okay? So that's your job for this week. Have a wonderful week. Those of you who are going to be at school soon, wish you the best. Don't forget to keep looking for my emails. And Martina's out.